G'day team, welcome back to another video. So we're actually going to be starting a new topic today. So we're actually going to start looking at vectors and scalars. So we're going to be starting by looking at chapter 3a.1 in the Hazy 11 specialist textbook, okay? So quantities which only have magnitude are what we call scalars, okay? Quantities which have magnitude and a direction are what we call vectors, all right? So they're our two starting definitions. So for a quick example, the speed of a car is scalar, whereas the velocity of the same car is a vector, all right? Velocity has a direction, so that means it's a vector. Other vector examples are momentum and force. A lot of physics will actually use vectors, so if you're interested in physics, this is a good starting point for your vector work in physics as well. So we represent vectors with arrows, all right? So the length of the arrow represents the magnitude of the quantity, and the arrowhead represents the direction. So for an example, a car travels at a velocity of 100 kilometers per hour in a southeasterly direction, okay? So we put in our reference coordinate north, okay? So we always put in our reference north, and then because we're heading southeasterly, that is down to the right 45 degrees, or if we're looking here, 90 degrees plus our 45 there, so 135 degrees, and we've got a nice long line here because my scale, 1 unit represents 20 kilometers per hour, okay? Another example, Mr. Virgo, myself, I'm digging a hole at 10 centimeters per minute at 150 degrees to the ground. So again, our reference point is straight up, and 150 degrees, we're actually rotating all the way around. And you can see that I've gone, so my scale is 2 centimeters, okay? So every 1 centimeter is 10 centimeters, so I've actually gone down 20 centimeters at my angle there, all right? So if you are given a direction like north, south, east, or west, then it's really important that we put in this reference direction, okay? So a bit of vector notation, all right? So we've seen here that they're represented by arrows. So here we've got the vector from A to B. So we say that vector AB is the vector that originates at A and terminates at B. So we read our vectors from tail to tip. We call this the tail of our vector, and we call this the tip of our vector, all right? And we can also call this, the vector AB is the position vector of B relative to A, okay? So both AB, so with our little arrow like this, a little half arrow, and AB with a full arrow are correct notation. I tend to use the half arrow. You can use whatever you like. So two vectors are equal if they have the same magnitude and direction, okay? So all of these vectors here are equal. Doesn't matter whereabouts in space they are, as long as they have the same magnitude and the same direction, these vectors are all equal, okay? We can also have geometrically negative vectors. So this occurs when two vectors have the same magnitude, but they have opposite directions, okay? So that could look like this, all right? So remember, we label our vectors from tail to tip. So this one is AB, and this one is BA, all right? So we say BA is the negative of AB. So we write vector BA equals negative vector AB, all right? So a couple of other things will often denote vectors with bold letters. So vector AB could equal bold R. So you often see P, Qs, Rs, and Ss in vectors, all right? And then one other thing you might see is modulus of a vector, and this just means the magnitude of that vector, all right? So that should hopefully get you started on vectors. If you are playing along with the Hazy textbook, have a crack through questions 3a.1, 1 to 3, and 3a.2, 1 to 3 as well. We'll see you guys next time for a bit more vector work.